Hi friends, in this video we are going to study about introduction to BIM, that is Building Information Modeling. We will discuss about adoption of BIM in India and in various other countries. The major reasons of project failure was studied in one of the surveys which listed as 36% of construction projects fail due to poor organization and project management practices, whereas 20 and 15% projects fail because of missing project objectives and ineffective project planning. This tells us that despite of having existing tools and techniques, there is still a gap in the project management practices. We were already using CAD software, that is computer aided design softwares like AutoCAD from Autodesk, but it is not sufficient or enough to aid for project management. In CAD platform, everything is shown as a composition of points, lines and arcs. That is, the walls will be straight lines, rooms depicted as a composition of walls or a rectangle, door is just an arc. These compositions are only used to represent different building elements, that is, symbols are used by respective disciplines of architects, structural engineers, service engineers, etc. However, in BIM, that is Building Information Modeling, there is a building model and it consists of information. Therefore, in BIM, I is the most important thing: intelligent information. In BIM, there are no plans, elevation sections, or schedules. Each and everything is one and is derived from the single building model. This helps to bring about a huge consistency in drawings. In CAD, whereas a draftsman has to prepare different types of drawings, coordination drawings, by observing each and every multiple layouts and templates. Hence, there can be mistakes at times in copying the drawing from one place to another. However, in BIM, as soon as there is any change made in the main model, all the respective drawings of plans, elevations, and sections get changed, and there can never be an error of drafting. Thus, BIM is much more useful and advanced than CAD platforms. So, what exactly is the definition of BIM? Building information modeling is digital representation of physical and functional characteristics of a facility, creating a shared knowledge resource of information about it and forming a reliable basis for decisions during its life cycle from earliest conception to demolition. Some of the keywords here that we see are digital, physical, functional, shared information, and life cycle. Yet another definition of BIM is a shared digital representation of physical and functional characteristics of any built object which forms a reliable basis for decision. Here we see the key words as a shared digital representation, physical, functional, built object, and decisions. We see a final definition which is short and sweet. That is, BIM is a process that involves creating and using an intelligent 3D model to inform and communicate project decisions. So, what has been the need of BIM? 73% of surveyors believe that failure to adopt BIM will hinder the growth of sector. Today, projects are suffering from adversarial relationships, low productivity rates, frequent disputes, and lack of innovation. What BRIM provides is the visualization of project prior to construction itself, planning, scheduling, and controlling with better collaboration between client, architect, designer, and contractor. It helps to reduce waste, that is, provides lean construction, reduces design errors, and helps to fasten the planning phase. It also will provide information on scheduling, cost estimation, and quantity takeoffs, thus contribute majorly to advanced project management. BIM is useful throughout the project life cycle, right from initiation stage where the client is involved. All the inputs can be taken down by the architect and is fed into preparing a conceptual design model. This is further developed by the architect into a detailed design. In BIM itself, you can perform structural design analysis. Thus, the structural model is obtained. Next, we have documentation, wherein the quantity surveyor will extract different types of plans, quantity takeoffs, door window schedule, etc. These drawings can then be further sent to the factory for fabrication. The factory will use this drawing to properly cut and prepare the pre-engineered building. Once these building elements are shipped to site, BIM model is used by construction managers to plan and update the construction logistics. Also, the planning person at the site during the construction phase will update the elements that have been received and installed in the project. Thus, the schedule of the project is also getting tracked. Once the building is constructed, the information which is held inside the model will be of great use to the facility managers during operation and maintenance stages. That is, the HVAC, lighting, plumbing, firefighting information is used for maintenance. If any particular lighting fixture is damaged, you can go to the BIM model and check what the specification, warranty, brand of the light was. This makes complete project management a seamless process throughout the life cycle. Next are the BIM levels. The BIM maturity can be calculated by at what BIM level the particular project is in. BIM level 0 is CAD, which was used in 1990s as plain 2D drawings. BIM level 1 that began in 2000s is 2D and 3D modeling. Further, BIM level 2 means actual use of information into these models, that is intelligent modeling, that began in 2010. Whereas BIM level 3 is building lifecycle management, that is use of this intelligent model along with transactable and interoperable data, which is now being used from 2020 onwards. We will now have a quick overview of how BIM is adopted across various countries around the globe. US somewhere leads the race with maximum number of BIM users. The BIM standards in USA mandates the use of BIM level 1 in all projects. 45% growth in BIM usage is seen in last 3 years. In Europe, the UK country has shown 39% adoption of BIM in 2012. The government has mandated requirement of full BIM by 2016. So we believe that UK has implemented complete BIM for construction phases, whereas France was going to do the same in 2017. South and Central Europe show 14% adoption. China shows 5% adoption and it is strongly growing. Korea, Japan have also laid their roadmaps in implementing BIM, whereas Singapore country has gone far to make it mandatory and compulsory for all projects to involve BIM and shows 50% BIM adoption, which is highest in any Asian country. Australia also strives for strong BIM adoption. The BIM adoption in India, however, has been very poor. There is no policy mandating the use of BIM. There is no political support. The industry engagement or awareness is also low. India can be said to be currently in BIM stage 1, that is use of only 3D models. The BIM is largely an experimental stage in India. In the eastern region, the availability of BIM trained professionals is even lower. There is some skepticism in the market as there is no leaders or success stories for BIM. However, it is now continuously growing with more large and complex projects coming up. It is now used in very few large contracting and project management consultancy organizations only. Though the popularity is soon catching up, there is few experienced professionals working in this domain. Some of the main reason is non-availability of softwares or is high cost. Some of the most common BIM softwares used are Autodesk Revit and Autodesk Navisworks. Autodesk Revit is almost 79% used throughout the globe. The next major software used is from Autodesk itself, that is Navisworks. Then we have SketchUp, Bentley MicroStation, Trimble Tekla, and then Graphisoft ArchiCAD, etc. Whereas while we look at the cost, the most cheapest BIM software is SketchUp, then it is Revit, then there is Navisworks, and the costly BIM software is Bentley MicroStation, which goes to annual subscription of $5,566. Some of the BIM softwares used as per function is shown here. For experimental or initial LOD planning, we can use simple tools like MS Excel, MS Project to plan the schedule. Once we start authoring the model, that is, to create a 3D model, we have to use Revit, SketchUp, ArchiCAD, Intergraph, Tekla, etc. To carry out analysis of these models like clash detection, you need to use Navisworks, BIM 360, BIM Track, BIM Collab, etc. And finally, to use this model in practical project management purposes like 4D simulations, 5D cost estimation, etc., we use the software like Synchro, Trimble Connect, Vico Office, Microsoft HoloLens, Building OPS, etc. Here we have provided an extensive list of softwares which is used for different functions of construction like architecture, structural, MEP, facility management, sustainability, and during construction, that is simulation, estimation, and analysis. All the most commonly used and easily available software for each of these special functions are mentioned. For example, for sustainability analysis, we tend to use Autodesk EcoTech, Design Builder, Graphisoft Eco Designer, or Autodesk Green Building Studio. For MEP, we use Autodesk Revit MEP, CAD MEP, or Bentley Havacomp Mechanical Designer. For construction analysis, we use Vico Office Suite, Bentley ConstructSim, or Autodesk Navisworks, which is most commonly used for clash detection and 4D simulations. For facility management, Bentley Facilities tool or Ecodomus is famous. This shows that BIM can be used throughout the project lifecycle in various functions and helps to give a cutting edge project management tool and technique. Thank you.